Hello everyone. This is Chi Jiaming, your instructor for the Deep Learning course. Let's get started with our lesson now. Hello everyone. Welcome back to our Deep Learning course. Today, we're in Chapter 3, TensorFlow Implementation of Neural Networks, 2, and we'll focus on Part 3.3, TensorFlow Implementation of Linear Regression Model. I'm your lecturer, Chi Jiaming. Let's dive in. First, let's recap 3.3.1 Linear Regression Model. Its core is to build a linear link between inputs and continuous outputs. Here, beta is a parameter matrix of size p multiplied by q multiplied by 3. These are the weights the model will learn. Epsilon is a scalar error term, representing the gap between predicted and actual values. Our goal is to optimize beta to minimize epsilon, so the model maps inputs to outputs accurately. Now, let's move to 3.3.2 case, food image scoring. First step, load the dataset. We use pandas to read food score CSV into master file. Then we print its shape to check dataset size and show the first 5 rows to peek at the data structure. This helps us confirm the data is loaded correctly. Still on the food scoring case. Next, we analyze the score distribution with master file. Hist, which gives a histogram of the score column. Then we use numpy, extract image ids from id as file names, and reshape the score column into an n multiplied by 1 array y. N is the number of samples. This preps the target variable for the model. Let's visualize the data to verify. With matplotlib, we create a 2 multiplied by 5 grid of subplots. We loop through the first 10 samples, display each image xi on a subplot, and set the title to the rounded score yi. This lets us confirm images match their scores, no mismatches here. Next, split the data for training and testing. We use train test split from sklearn, split image data x and scores y into x0/x1 training or test images and y0/y1 training or test scores. We set test size equals 0.5 50% for testing and rand state equals 0 ensures the same split every time for reproducibility. Now, let's design the linear model structure. The flow is input layer image data x, flatten, straighten 2D images to 1D, vectors, full connectivity, dense, output layer, score y. No activation function is used here because we need continuous scores, and linear regression doesn't require nonlinearity. After building the model structure, model compilation is a must before training. It tells the model how to learn. For our food scoring, a regression task, we set 3 key things: Atom as the optimizer for efficient parameter updates, MSE as the loss function fits regression, penalizes big errors, and may or RMSE as metrics to check prediction accuracy. Only after this can we start training. Now train the model with model fit. Use x0/y0 training data to teach the model and x1, y1 test data for validation. Batch size equals 100 means we shuffle samples and split into 100 sample batches efficient for training. Epochs equals 100. The model will go through the training data 100 times to optimize beta and reduce error. Finally, use the train model to predict a new food image. Steps. First, load mipik.jpg with image library. Second, resize it to imsize. Imsize, match training image size. Third, normalize pixels, divide by 255, scale to 0 to 1. Fourth, reshape to 1, imsize, 3, add batch dimension. Fifth, call model. Predict mypic to get the predicted score. That's how we put the model to use.